Although it may seem weird to think about seeing back in time, space researchers do it every day. The James Webb Space Telescope, JWST's magnificent images of our universe have made this year one to remember. These are images that allow us to observe faraway galaxies in their pre-13 billion year state. It's the ideal moment to take a step back and be grateful for both our first-class seat on the cosmic elevator and the ability these photos give us to travel across time. The early universe, star birth and death, galaxy mergers, and planetary atmospheres are all depicted in these images. The JWST scientific discoveries are beyond believable, and it keeps breaking barriers. But how did the James Webb Space Telescope enable us to observe the universe's very first galaxies? Which of its findings break the laws of physics, and have we discovered any signs of life elsewhere in the cosmos? Join us as we explore how the James Webb Space Telescope just discovered galaxies that defy modern physics. The speed of light is one of the most well-known rules of physics that govern our universe, and when we refer to light, we actually mean all of the electromagnetic spectrum's wavelengths, which move at a staggering 300,000 kilometers per second. Light moves so quickly that it seems to happen instantly in our daily lives. However, traveling anywhere in the galaxy still requires some time, even at incredible speeds. When you stare at the moon, you actually see it as it was at 1.3 seconds ago. Even though it's a very brief glimpse into the past, it is still the past. The only difference is that photons, light particles emitted from the sun's surface, take slightly longer, over 8 minutes, to reach Earth. The Milky Way galaxy, our galaxy, is more than 100,000 light-years across, and the lovely young stars visible in the Carina Nebula image from the JWST are located 7,500 light-years away. In other words, the historical period represented by this nebula is around 2,000 years earlier than the time when ancient Mesopotamia is supposed to have developed the first form of writing. We are constantly looking away from the Earth and towards the past at how things once were. Astronomers can utilize light as it has been observed across time to try to piece together the mystery of our universe. We can observe some light spectrums with space-based telescopes that are blocked by Earth's atmosphere. The ultraviolet, UV, and visible portions of the electromagnetic spectrum were used in the construction and optimization of the Hubble Space Telescope. The JWST, on the other hand, was built to work with a variety of infrared light, and this is a significant factor in why the JWST can go further into the past than Hubble. Gamma rays, radio waves, and all other wavelengths on the electromagnetic spectrum are all emitted by galaxies. All of them provide crucial details about the many mechanics operating in a galaxy. On July 12th, NASA released some of the James Webb Space Telescope's first breathtaking images and data to the general public. The 4 targets, each of which is made up of 3 photos plus a spectrum, beautifully capture the infrared world. President Joe Biden made a 4th image, a sharply focused, ultra-deep field view, public on the night of July the 11th during a live broadcast. This image showed an older universe than anything we have ever seen. The images and data show how James Webb has evolved into a useful research instrument, highlighting the telescope's great potential to advance science. The Stephens Quintet group of galaxies, the Southern Ring Nebula and the Carina Nebula, are depicted in the 3 photos. The 4th target is the spectrum of WASP 96b, a gas giant exoplanet. The Carina Nebula, one of the largest and brightest nebulae in the sky, is 7,600 light-years away from Earth. It contains Eta Carini, a fading supergiant star on the edge of a catastrophic explosion, as well as Trumpa 14, one of the newest known star formation clusters. Its diameter exceeds 300 light-years. The Carina Nebula is a large, active, and occasionally violent star nursery. The place is humming with activity, which is very wonderful. This stunning image from the Webb telescope of the cosmic cliff of the Carina Nebula provides new details about this massive stellar nursery. Additionally, we are now able to observe brand new stars for the first time that had previously been completely hidden from view. In contrast, the Southern Ring Nebula is only 2,000 light-years away from our planet. It is a planetary nebula, a rotating gas cloud of a dead star that is expanding. Unbearably hot and emitting powerful ultraviolet radiation, the dying white dwarf star in the nebula's center illuminates the gas surrounding it. Every one of its outer layers has been blown off. The newly discovered parts of the nebula are visible in the photos, along with the gas-formed shells. 5 galaxies known as Stephan's Quintet are 290 million light-years away from Earth, but seem impossibly close to one another. Due to their interactions, 3 of the galaxies have evolved into lengthy spiral-like formations, while the other 2 are engaged in a type of cosmic dance that will eventually lead to the collision of the quartet. The 5 stars in the group range in age from very young to quite old, representing hundreds of millions of years of cosmic history. Not every significant picture captured by the James Webb Space Telescope will, however, be visually pleasing. Some of them will be maps like the one NASA recently unveiled, which consists solely of lines, dots, and squiggles. The striking impact of Webb's view of galaxy clusters and the magnificent beauty of the Carina Nebula image are missing from that graph. The tiny map is intriguing in its own quiet way, though, as are the numerous other charts that the Webb telescope will produce over the next 20 years. These photographs will push our capacity to imagine the characteristics of worlds that are far outside of our solar system. Naturally, you must first be conscious of what you are viewing. A large gaseous exoplanet that resembles Jupiter is shown in the figure with extensive information on its atmosphere. WASP 96b travels around its Sun in approximately 3.5 days and is 1,150 light-years from Earth. The temperature inside it exceeds 1,000 degrees Fahrenheit, about 538 degrees Celsius. The only known cloudless planet, WASP 96b, has remained a mystery and a top area of interest for further study since its discovery in 2013. Webb's new observations have provided scientists with more knowledge about that unusual atmosphere. When Webb examined the starlight that reached the exoplanet's atmosphere, it was able to spot the telltale sign of water and even evidence of clouds. On this incredibly hot planet, clouds are quite unusual. Because rock is so heated, it can condense in the air like water does on Earth. But unlike Earth, sand makes up the clouds on WASP 96b. It became obvious that many other substances besides water will condense under the right pressure and temperature conditions. Exoplanets will no longer be viewed as enigmatic cosmic objects, but rather as very real locations with an alien sky thanks to the Webb telescope. There are an estimated 300 million planets in the Milky Way galaxy alone that may be habitable, and several of these planets are barely 30 light-years from Earth. In a sense, humanity's neighbors in the galaxy are these planets. The most distant confirmed galaxy prior to the James Webb Space Telescope's deployment was GNZ11, which astronomers observed when it was roughly 420 million years after the Big Bang, giving it what astronomers refer to as a redshift of 11.6. Redshift is a term used to express how much the universe has stretched the light coming from a galaxy. The further back in time we perceive a galaxy, the higher the redshift. We'll be able to observe incredibly far-off galaxies with the JWST as recently as 100 million years after the Big Bang, which took place some 13.8 billion years ago. Therefore, light from 13.7 billion years ago will be visible to us. However, the fact that those galaxies are not 13.7 billion light-years away is about to turn your head. That is because those galaxies are currently 46 billion light-years away from us. This mismatch, which makes operating on a very large scale difficult, is entirely due to the expanding cosmos. Dark energy is something that is causing the universe to expand. It is believed to be a universal constant that operates uniformly over all of space-time, the fabric of our universe. And the impact of dark energy on the expansion of the universe increases with its size. Because of this, the cosmos is actually about 93 billion light-years across, despite being 13.8 billion years old. On a galactic scale, we are unable to observe the impact of dark energy inside the Milky Way, but we can do so across much longer cosmological distances. A week after the first JWST science photos were made public, astronomers announced the discovery of galaxies at redshift 13, or roughly 300 million years after the Big Bang. The record is currently being broken by a new wave of scientific discoveries, with some astronomers reporting the discoveries of galaxies up to a redshift of 20. If this is the case, then we are witnessing these galaxies in their pre-Big Bang state. That's a big if, because none of these redshift estimates have been verified as of yet. It will take spectroscopic study, which divides an object's light into a spectrum, to verify the distances of these galaxies. The analysis will be presented later, but it is apparent that JWST is completely able to find galaxies from this long-gone age.